Then these are some of the terms what we are using in the torsion theory. All right. Some terms are torque. What is torque? Torque is nothing but when we apply a force like this. This is the some force, this vertical force, and opposite to this vertical force, right? This is upward force and it is downward force. The equal and opposite parallel forces will make shear, is it not? So when you apply such type of forces, that the moment will develop, right? That is turning force. So torque is nothing but turning force multiplied with diameter of shaft, right? This force into perpendicular distance, that is force, turning force into diameter of the shaft, that is force F. Diameter, what is the diameter? 2 times the radius, that is 2r. T is the torque, F is the turning force, R is the radius of the shaft. What is the unit for torque? It is nothing but Newton per m, Newton mm, or kilonewton mm, or kilonewton meter, right? Then the next term, angle of twist. What is angle of twist? Suppose it is the cross section of a shaft and it is the center of the shaft and a point A, right? And the angle is, the center is O. During the torsion, this A displaced to A dash, right? A dash, the angle between A to A dash is theta. This is angle of twist, right? Alright, the amount of twisting, that is the amount of twisting is known as the angle of twist. How much amount that twisting is made on the shaft is known as angle of twist. It is measured in radians, right? Angle of twist depends on applied torque, that is T, and length of the beam or rod or shaft, that is L. And then modulus of rigidity G and torsional constant J. These 4 terms affects the angle of twist, right? Then what is shear stress in shaft? When a shaft is subjected to equal and opposite end couples whose axes coincide with the axis of the shaft, right? Coincide with the axis of the shaft. This is coincide with the axis of the shaft. The shaft is said to be in pure torsion. And at any point in the section of the shaft, stress will be induced. That stress is called shear stress, right? That is, when you apply a force with the axis of the shaft will get pure torsion. Because of this pure torsion, the stress developed is called shear stress in the shaft, right? In the torsion theory, we consider some assumptions. The following assumptions are considered to determine the angular twist and shear stress under the twisting moment. When you apply a twisting moment, the shear stress and angular twist will be developed in the body or the material and the member. So, in the theory of torsion, we made some assumptions. The assumptions are: the material is homogeneous and isotropic. The plane cross section is the remain plane even after deformation due to twisting moment. The twist is uniform along the length of the shaft. The displacement or strain at a point in the shaft is proportional to its distance from the center of the shaft. Then, what is power transmitted by shaft? How to determine the power transmitted by the shaft? The power P is multiplication of mean torque and angle turned per second, that is 2 pi nt by 60. N is nothing but rotations per minute of the shaft. T is the mean torque. Then strength of shaft. Strength of shaft is the maximum torque that can be resisted by the shaft. Actually, in the shaft at the center, the shear stress will be 0, the torque will be 0. But at the surface, the maximum torque will be. So, the strength of shaft is the maximum torque that can be resisted by the shaft. This strength of shaft can be determined using the torsion equation. We will discuss this torsion equation in the next video. This is the torsion equation. Using this torsion equation, we can determine the strength of shaft. As I already told, there are two types of shaft. One is solid shaft, the other one is hollow shaft. Right? Generally, the shaft will be in circular shape. So here we discuss about the circular shaft. Tau is the shear stress, R is the radius, T is the maximum torque, J is the polar moment of inertia, G is the modulus of rigidity, and theta is the angle of twist, L is the length of the member. Right? Here the J value is given here for circular shape. This is the constant value, that is pi d power 4 divided by 32 for the solid circular shaft. Whereas for hollow circular shaft, it is nothing but outer dia minus inner dia. Outer dia minus inner dia. Pi by 32 into d, capital D, that is outer diameter minus inner diameter. The strength of solid circular shaft, that is maximum torque, T, can be determined using this formula. What is that? Pi by 16 into shear stress into d cube. Similarly for hollow shaft, pi by 16 and tau is same, but instead of diameter here, outer diameter minus inner diameter. Right? Okay. With this, the torsion theory is over. In the next video, we will discuss about the torsion equation. Thank you.